Hello, this is Mr. Sullivan, and today we're going to look at this very tricky probability problem. I'm going to show you two ways to do this. The first way is the way I did it, which is kind of complicated, but it's useful because it shows you some good strategies. The second way is the easy way, and if you can remember the easy way, you're good to go. Okay, there are 4 students of all of different heights for it to be randomly arranged in a line. What is the probability that the tallest student will be first in line and the shortest person will be last in line? So what I like to do with problems like this is I like to make a list, draw a picture. In this case, I'm going to list out all the possible arrangements. So what I need to do first, I need to actually give all these students a name. So this is math, so we want to keep it simple. We're going to name student A, student B, student C, and student D. Right? We want the tallest person to be first. Let's say that A is the tallest, and D is the shortest, and we want them to be last in line. So this would represent a desired outcome. We have A, the tallest person first, and D, the shortest person last. Put a little star next to that. But now what I need to figure out is how many different ways can we arrange these 4 students. So what I'd like to do is I like to be systematic. I got A, B, and then what I can do here is I could change the D and the C, changing as little as possible, trying to list all the possible outcomes beginning with A. So then I could also say, well, if I got AB first here and AB first here, there's no way I can do AB again. So let's try out C in the second position. So then I like to keep my letters going in order, so then I'd have B, D, or A, C, D, B. And all I'm doing is I'm switching the last 2 in each case. So I've looked at all the ABs, I've looked at the 2 ACs, so let's see what happens if I start with A and then D. I could say BC or ADCB. Now in all of these cases, we've met that first requirement. A is the tallest and A is first. But this is the only one that has D, who is the shortest, last. So these are the only 2 ways that we can arrange the students where we have A first and D last. Because now, if I'm looking at the rest of my outcomes, let's imagine student B was first. Well, if student B was first, then I could have B, A, C, D. And if I followed this same system, I'll have the same number of arrangements. We had 6 arrangements here. I'm going to have 6 arrangements starting with B. Then I'm going to simplify this. I'm going to have 6 arrangements that start with C. And again, I could list all these out, but I know I'm going to end up with 6 arrangements that start with the letter D. So that means I've got 6 plus 6 plus 6 plus 6. In other words, I've got a total of 24 different outcomes. So this is important because that becomes my denominator. Now I have to figure out how many of these arrangements have A first and D last. Well, since this is the only group with A first, and there's only 2 of them with D last, that means there's 2 out of the 24 satisfy the requirement of the problem. You could simplify this fraction by going to your calculator and you write in your fraction 2 divided by 24 and you get this answer, and then math, and you hit that fraction key, so you can hit enter and enter again. You've got a 1 in 12 chance. So I told you there was an easy way to do this. Well, let's think about this, right? What is the probability that our tall friend ends up in the first position? out of a possible 4 positions? Well, he could be in 4 of these different places, and we want him to be first. So the probability that he gets randomly selected to be in that first position would be 1 out of 4. Right? So we have a probability that student A ends up in the first position would be 1 out of 4. Now, just like in the last problem, we want A to be first and D to be last, so we're going to multiply. Now, if A takes up the first position, there's only 3 positions left for D. So there's a 1 in 3 chance that student D will be, the shortest student, will be in the last position. It's multiple events, so if I multiply these probabilities, 1 times 1 would give me 1, and 4 times 3 would give me 12. So this is the short way to answer this question, 1/4 times 1/3. Keep in mind this idea of multiple events in probability. Multiplying, if I want the tallest student to be first in line and the shortest person to be last, we can use multiplication. But if you forget, draw pictures, create lists, do something to try to get yourself points on these questions. Good luck with probability.